At Fest this year in Seattle, we showed this project, and we thought today we'd go in a little more detail and kind of dig in. So just to kind of refresh everybody's view on the project and kind of give you something to check out. Take a peek here. You just saw the cinematic. But what's really cool, because this is an interactive application, we can go through any time and change the colors and do that kind of thing. And today we're going to go through the experience. I'm going to share some of the blueprints and how we put the systems together. Andy's going to tell you about the data and that kind of piece. So we're going to be really open about what you need to look out for, the things you need to check into, and kind of how you approach these kind of projects. So as the cinematic finishes up here, I'll just run through the interface really quick. Just as a reminder, we have this orbital camera system that kind of lets you go around. And this is really like a typical web configurator or visualizer that folks would put together. And a lot of the people, even on this session, they do this every day. So I think what's really cool about this isn't just that, we're showing it, but that folks are actually doing it. We have some of the common features here. We have the, the different colors.
I love that
in
blue.
the UI. Yeah, the blue turned out really nice. And yeah, so I'm gonna take the controller here actually and start to fly around. So, we have this functionality where we can really get in and take a peek. And, what's really cool, like you were saying about that blue, and I'm gonna get really close here because of the zoom compression, but using substrate for these different materials and kind of putting that fit and finish together was something we were pushing on. This project was to pressure test Unreal and kind of get a feel for the editor and see what it could handle. Again, just for the folks watching this, we didn't gamify this model. This is a straight CAD model that we brought in, left it, in its hierarchy.
So we're looking at like full resolution, like there's all of the polygons that were in games in 1999 and inside of one wheel right there.
That's a good way to look at it, and as we kind of get into these other modes, we can fly around and take a peek and start to pull things apart. As we pull these things out, I threw a little flashlight in here.
This is amazing. I had no idea that BMW's doors were so complex until I looked at this this awesome model here.
I think we get spoiled as like when we're doing data prep and data management that we kind of see all these supporting surfaces and the amount of work that goes in by the engineers, right? They spend a lot of time kind of perfecting this stuff, and being able to pull it around and take a peek at it,
the ultimate mechanic simulator.
Yeah. Another really cool spot of detail that in Flow, you can kind of talk to Sam, speak about this, but having these the substrate model, we were able to like get in here and really take a look at things like the layers of I'll go back here a little bit, take a look at the layers of the glass and kind of how
along the sides there. It looks just like a photo, like what I remember my BMW sunroof looking like. The only difference between this one and mine, this is a lot cleaner.
Yeah, you always have those people at the auto show. They're always, cleaning the cars up, And I left this in for a reason, so you guys can all see this sphere that's kind of like right in the middle of the view, and that's kind of a part of the blueprint system. So I'll talk about it later in more detail, but the way that we're doing this little highlight is really neat, and this little mesh swapping thing I'll definitely talk to. So the pull apart system is pretty cool. When we go out, everything goes back together, which is really important, obviously. A couple other features that are worth, we have the path tracer right in here, so that probably is a little fast for zoom. But the cool thing about having these different paints, even in the path tracer, I can go in here, and what's really crazy is I can start to tear this thing apart even in path tracing mode. So it's not maybe super practical, but the fact that we can just like do that is just kind of absurd to me. I can turn the flashlight on and it just starts to
especially
clean
in
up
real
and do its
time,
thing.
and then the detail that it has, like you can see the individual stitches in the seat, which that always breaks down whenever you're looking at something that's been gamified, because we got to do it all in a texture map. Here we've got physical geometry for pretty much everything, and it's amazing.
So there's a bunch of really powerful things going on here. So in this system, there is a this camera system down here where you can go in and you can actually like pick these different bookmarks. And then there's a free floating camera here. And so what we can do in Unreal, which is really cool. So over here on the blueprint, you can see in this level, we have all these blueprint actors, these cameras here. And if I press our favorite button, G, we can see that there's all kinds of cameras in this view, right? So I worked with the team to set up all these positions. And what was really cool about this system is that I could basically build out this blueprint camera configurator with a custom class. And we know in games like how powerful it is to have those custom actors, those blueprint actors, because we can always find them, right? We can always find them not only in the levels, in the maps that we're making, but also in all the projects that we've ever done. And because we made this out of a plugin, you know, as we start to improve or change the system, it just kind of rolls out everywhere, right? And so I just want to show in a little bit of detail here the benefits of making your own classes, right? So we just looked at this camera blueprint. So again, this is the free camera, and then this menu is made dynamically when you hit play.
So that means that any camera I plop in there, just put the camera in and worry about its positioning, its f-stop, its field of view. No worrying about actually linking it up to the blueprints because we've already done that. We just drop it and worry about the artistic stuff.
Yeah, what's really cool is that so this is what that blueprint looks like, right? So we have a blueprint camera configurator, and it's just basically an actor blueprint. Go over here, show you that. So, you know, it's just parent class of an actor. And so this blueprint really is just comprised of a cine camera, you know, put under the root. And the magic here and what's really cool is that it also has a widget associated with it. So what basically happens is that I made a really simple thing, right? It's a camera and a one variable, effectively. When you start the play, like on begin play, when we hit play or start the game, it basically generates a button widget right off the bat. So it creates that widget and holds it. We've saved it in the variable, so we know where it is. And that's a really cool thing that Unreal can do, is because now we have a camera that has its own button kind of in its own class. Like that object knows what it needs to be. And so we made this button class, this is a widget blueprint here, that's just called widget blueprint button selection camera. And we use the normal convention. Again, it's easy to find my stuff because I just type WBP and all my widget blueprints pop up. That's not like required, but as you build out those kinds of the lexicon in your setup, it becomes really apparent what's going on. And just to quickly go through that blueprint, you know, basically it's a widget that has a size, obviously, and that's configured. And it's got a background, an icon, and a number. And when we look at the graph for that down here, what's cool is when it pre-constructs, that basically it makes its own material instance that then can be affected by the system. It sets its background, right? And we're passing this stuff in, right? So then it sets its background, sets up its texture, sets up its number, right? And so if you take this stuff kind of one step at a time, Blueprint's really cool about that because you can kind of focus on one thing at a time and do what you need to do. And then the button has its own, right? The button widget has its own logic for not only itself, but for its UI events. So if we look at the button, right? This is the button that I was just showing you. This is these are all the variables that are that are set up there. So you can see that the camera, so the button also knows the camera, right? And it takes in a camera, a widget, and a name. So it knows what to call itself. It knows what camera it's a part of, and it knows what its parent is. And so when you click the button, there's a really important thing that is utilized in a few of these systems, which is the blueprint interface. And so when this button's clicked, it knows what to do when it gets clicked by itself. And so separating out those ideas between the different actors and the different components in the scene really starts to make a powerful toolbox that you can use in a lot of different ways. So basically, you know, when you click this button, it does the blueprint interface to say, hey, I got clicked. And it says who got clicked, what their name was, what this widget, what this button that got clicked, and what camera it's related to. So you're sending that out to Unreal, and everything that's listening for that, right? We call it callbacks in a lot of other systems. That calls out and says, "Hey, I did a thing." And then the other thing that this does is it'll handle the actual like when you click, it changes the color here, right? It's just changing the the player. If you go to the default view, this will take you back to the floating camera, right? So like if you're not in the default view, right, then you get a bookmark. But if you have the default view, then it'll take you back to the free floating camera, and that's
So
the
it's a way to
transition
kind of like
there.
easily transition so there's no jarring camera movements.
Yeah, it blends you between like the camera here, so you can see this connection, to the player's pawn. So it kind of like
Awesome.
constrains you and brings
Yeah,
you
that's
back.
great.
This is the kind of stuff we couldn't go into detail at Fest about that we really wanted to take a minute and look at. And then this is the hover, right? So this is where when you hover over it, it just changes the value of the material, so it gets that light up kind of effect for the background. And I just wanted to showcase really quickly that there's a library of these things that we've built out in this plugin. So we have the textures, right? So these are all the textures that we're using in the interface. And these are all the materials that we're using across
Very
there.
cool.
So, like when you see that reticle or whatever, that's where that material is defined. Um, and so, at runtime, the camera, the pawn is actually making that whole HUD. So everything that you see doesn't exist until you hit play. And so in the pawn, and I'll go into the pawn more later on, but there's a function that's called setup HUD, right? And it returns the HUD so that Unreal knows, which one that pawn does. The reason that's important is because it starts to inform the system that you may want multiplayer someday. Because
Okay.
every pawn gets its own HUD, right? And you need to have that, unique.
This is kind of future-proofing yourself in case somebody decides one day, hey, we want this to be a multi-person config.
Because you know how that goes, right? If
Yes,
you don't
yep.
start network replicated, you don't start thinking multiplayer, it's harder to back into it. But that setup HUD's just basically setting up that car configurator widget, just like I showed how the button made itself in the camera. This has a whole car configurator widget, which is it looks like this. It's living right here. It's just a widget blueprint, right? But it's set up to look like the shot that we see.
Nice.
And so some stuff you see here, you don't see by default, and that's all handled by the default visibility and some of the graph and the design. And a lot of this stuff stacked on top of each other over here, right? So these are the different modes, and we're basically moving them around with Blueprint. This is what that graph looks like. I will not be going into the full detail, but I want to show something really important right off the bat. You see the colors.
Yes.
A lot of folks, when I look at their blueprints, they don't have an organization system for at a glance. And I'll really drive that home with the pawn as well. Like I know that this red stuff is an event, right? And this is HUD related, right? And
Okay.
so the reason I do that is because like this is all my begin play. When I'm trying to debug or I'm trying to work on this, I know the green stuff happens first, right? And that's
Very
just something
smart.
I decided. But being able to save those colors in the palette is really huge.
Well, I think this is also useful, especially if somebody else comes onto your project, and they don't know anything. It's really, really, really hard to look at a massive blueprint graph, material
Yeah.
graph, any massive graph, if you haven't built it from the beginning and be like, dude, where do I even start with this thing?
Exactly. So when I refactor stuff, and of course, as you're working, it looks more like this. I left,
Yeah.
some of the, it's okay to have, that, but take the extra minute and just take the time because, the other thing is that I'm using functions, and I'll go into this later with the pawn, but like make it easy on yourself. Like use your functions, use your macros, collapse those nodes because it can be overwhelming, right? And so basically when we fire up that configurator widget to draw the UI, right? We have an initializer. And then we start to set up all the events, like what happens when I select cameras, right? And this initializes all that camera stuff. And then these are just some of the things, but like the way that the animation plays, right, is in here. And it starts to bind in and do all this stuff. So this is in the this is all the stuff that the interface is concerned about. And
Okay.
having a strong idea of like model view controller where like the UI does the UI stuff, the pawn does the pawn stuff, the car does the car stuff. that gets really important. So I use this in a couple of different areas, and and the UI basically goes through and sets up and generates all the buttons. So I use this in a few different ways in the project, and yeah. So now I'll turn it over to Flo.
So, hi guys. I will take a step back and basically move the whole thing a little bit, just one layer higher than what Mike just did. And we are talking about the whole architecture overview. Like, how did we structure this, and what are the benefits of how we worked here? So essentially, when we were collaborating, right, we were collaborating over several different time zones. Like Mike is in the US, on the East Coast. We had our creative director and also our CEO sitting in LA. We had Andreas and I, we are obviously in Germany. So working on the same scene with just several people at the same time is always a little bit of a challenge, right? So while the key is obviously communication, we very quickly went into one file per actor and the whole word partition topic. So the way this is structured is we have the main map, and we work with so-called content plugins. Content plugins is a way in Unreal how you can, well, put content, blueprints, whatever you want, meshes, assets, levels inside a plugin, which allows you, especially when you update things, everything is contained in that one plugin, right? And if you update certain things, you only need to update that one little plugin, which makes everything much, much easier, especially when you work with things like Perforce, or if you're talking about distributing your stuff to a live system and so on. It's just way easier. So essentially, how this is ideally structured and how we try to go about it is we have a material library plugin, which holds the textures related to the car, right? We have all the data, like any kind of data, like data structures, manifests, whatever you need. It could be an XML file, a JSON file, whatever, right? We store all of that stuff. We have the materials, which allows us because also we have the material separated from the car. What this allows us to do is essentially use the materials for several different cars, right? It could be the car paint or the leather and so on. We don't need to store that several times. We just store it in one place, and we can always swap out the plugin. We can always update the plugin, and so everything in the whole chain gets updated, and all of the cars. Then we have another plugin, which is essentially the car. In our example, it's the BMW 5 Series, right? With all the geometry, with everything in there. This is also where we store the CAD materials, which we are then exchanging for the actual materials that we are using. We have all the cut meshes, the soft parts, obviously, and small correction to what we said before. Obviously, the car, not the whole car is CAD data, because for things like the soft parts, so like seats, the steering wheel, the leather on the steering wheel, those are handcrafted, those are hand modeled. And then again here, like everything data related to the car, right? Variant set, data tables, structs, and so on. The other thing that is referenced in here, the other big thing, is different environments, right? You can have different environments. Obviously, this is a very, very simple environment that we grabbed from Twinmotion and exported directly from Twinmotion, because the focus of this experience obviously was the car. We also have a plugin for where you store different cinematics, right? Like camera flights and so on. And you have a plugin where you want to store all your UI assets, like all your icons and so on. You can see here. So this is the structure, how we structured the whole car essentially. And this here, so all of those CAD, all of those files, You can see the whole CAD structure here, right? This is all inside the plugins that I mentioned before, right? So here plugins, then we have the G60, we have exterior, and we have like here is the whole CAD, all the import folders and so on. And just so you guys have seen this, so this is really because I saw the question in the about how we did the post process, the selection that Mike was showing before. So we are not, this is not merged just because somebody else that all of this is really single, and I just want to call that out. So going back to the plugins again here, like we have the desert, right? Again, this is just a level. It's its own level, and it's in here again, right? So this is the desert. I can toggle that on, I can toggle that off. And the way you actually control all those things is with data layers. So we organize, so every level basically, if we pick the desert one, right? You can see that down here in, so I'm using show only modified properties, so it's easier for you guys to see. But this one is directly linked to the env desert v2 data layer. And that data layer is up here. So we can toggle this up here and so on. And that's where we also can control the runtime capability of those levels and can control over the runtime state. So unloaded basically means it's just not loaded, and you basically have to load the level in if you switch to it. Loaded means it's loaded in the background, and activated, it means it's actually visible. So you can easily turn things on and off. And what this means is everything that is related to the environment, the lighting, the actual geometry, and all of that is in its own. So just to reiterate, it's in its own plugin, which is its own level. And this is tied to its own data layer. And this is how this is being controlled. So, and if you want to edit those things, what you can do is you just right click on it, edit, and then you have the possibility to also edit. And we will talk about the lighting in a later session. But essentially you can control all your things in here and turn things on and off. And it's just what it gives you is, as I said, it gives you several advantages in terms of swapping in and out environments, cars, all the data that you want. So the whole idea is the architecture is as flexible and as extendable as possible. So yeah, and with that, I would give it over to Andy to talk about Nanite. And that's what you're here for anyhow, guys.
Yeah, after we've seen the architectural overview of the whole experience we created, I am going back to a few basics. You may have seen that during the UE Fest talk in Seattle, but it's a whole challenge to get all the construction data into Unreal. For that, a while back, we created Datasmith for CAD import. It was heavily enhanced for the release of 5. We switched to a new translator library that gave us more possibilities in terms of support for different file formats, but also gave us the possibility to develop our own tessellation algorithm. So with 5.0, we shipped with the tessellation algorithm that came with the library. But since 5.3, our own tessellation library is default, which gives us the possibility to react faster to issues. In comparisons, we are creating a cleaner mesh with the same or less poly count, but in the end, it results in a better quality compared to the third-party library. And that's why the rule of thumb should be use always Epic's CAD kernel. It's on by default. If you encounter issues, you can always switch back to the third-party library via a CVAR. That will probably end up in a menu button in 5.6 or later. So we are currently concepting to clean that whole thing up and make it more user-friendly. In 5.5, it's still mostly CVARs. I'm going through these CVARs later on. Yeah, that's in terms of the CAD import in general. One important thing, and I think that's kind of unique in the industry, Unreal is building up a so-called CAD cache. This cache contains various folders. So we have the CAD folder, which is just a conversion of the imported CAD file in the native file format of this translator library. So whenever you try to re-import something, it just grabs the file here, and it's re-importing way faster than you would do that if you just re-import with a new file.
Oh, because the translation's already done.
Yes,
that's
exactly.
Really cool.
Yeah, so you have two possibilities later on: re-import, and it just grabs it out of the cache, or re-import with file. Then you can point it to a different file or to a new file, and it rebuilds the cache.
That's awesome.
But you can also, and I show that with the CVARs later on, force Unreal to rebuild the cache anyway, also on re-import. But yeah, as I said, these are all CVARs currently. Then we have the mesh, which is basically already the tessellated mesh. We have the scene, which just builds the scene structure, the empty structure without any geometry of the CAD file. And then we have the body, which is an equal to the U assets that are going to be created inside of Unreal. This is the last stage before they get passed into the editor.
Oh, nice. So you have like the translated step and the just before import
Yes,
step.
exactly.
That's so awesome.
Yeah. And for example, if you import multiple CAD files and for example, you have an assembly pointing to a screw that is distributed 20 times in your CAD product, then it just imports it once, converts it once. So there is some smart mechanism in the CAD cache that will help you for the import times. And it's heavily multi-threaded. So I was able to import the BMW 150% in about 3 hours, which is given the fact that we have all the configurations that are relevant for the markets here in there. That was really, really great.
That's absurd. Yeah.
I mean, it's an entire car, right? Like
It's more than an
It's
entire
more. It's a 150% model.
oh, it's
Yeah.
150%.
Explain what that means. Yeah.
Yeah, 150%.
So I could technically download this car.
So you basically have all possible variants in that scene. So for example, you can see it here on the rims, or you can, if I zoom in here on the seats, you have all possible seat variants in there. You have different bumpers overlaying each other. So you have the M Sport package or the standard package and stuff like that.
This is so cool.
So and in addition to that, you have explanation what the colors mean and stuff like that.
And you said it took 3 hours to get all of these parts imported.
Once the pipeline was set up. The important thing here is we did not get any special data set from BMW. We took the exact same data set that the agency later on used to create the car configurator in the dealership or for the WebCC.
So this is like the raw, pretty much the raw CAD data that an engineer would be building to make the doors and the fuel pump and whatever stuff. So
and
that's
those
awesome.
colors are a BMW convention. Like that's not something Unreal did. That came through the CAD, which is so powerful because the colors they mean something.
Yeah. Colors mean something?
Yeah, colors mean something. Put it on a shirt.
It's a good reference, but out of experience, I wouldn't always count on that.
Sure.
Because in the end, you can see it here. These gray parts are most likely metal. This part here is plastic. So it's not the surface material they're taking into respect. It's more like the physical material.
Physical material, okay.
Yeah.
But it's still something that comes through that you can base work off of. It's better than nothing with what, 50,000 components, 100,000 components. I have no idea how many parts are in a car.
What we ended up with was so the agency that pulled the data out of the PDM system at BMW created these folders for the components. And in the end, we had like, I don't know, 200 CAD products that were linked to around about 4,000 to 6,000 CAD parts. So it was an assembly system. And in theory, as it was handmade, you double up geometry quite easily. So for example, if you have a CAD product, so assembly for the doors, you have the outer shell of the doors, all the mechanical parts, the inner shell, and then you have, for example, the chassis or the mechanics, and then you have mechanics of the door in there as well. So this was something we needed to get rid of manually, because if we would have done it in an automatic way, then it would have been pretty hard to see where we should delete something and where not.
So you could have like the door, but it could have like another door on side of it that's for something else in CAD. Maybe like a placeholder door or something like that there.
Exactly. Yeah. So what we focused on was in our first step to get rid of these things, these cones, these manufacturing information, like foils, or you can see that in this screenshot here. These are areas where you put parts on top of each other. So it's really manufacturing information, tolerance information, stuff like that.
Make sure like there's the gap between the doors and things like that.
And that's something you really don't need. So we set up a blueprint that is based on a data table. And this is a snapshot, by the way, of the data table. So like Clinchpunkte, it's all German, of course.
Well, it helps that you pronounce that so well.
Yeah. And this can grow over time. So the more data you import, the more information you get, you want to filter out. And this was a great first step to see, okay, I have imported everything. What do I actually have and what do I actually need? And it was also great to see, because of the logging, is there any part not importing at all? Do I have to do troubleshooting, following up? So the log file is really important, because you see, okay, next task, this Linsenschraube, Kunststoff, etc. Is translated, and then you have 2 of 84 threads running and stuff like that. So this helps you a lot for troubleshooting. And why we used Interchange. I mean, you could have done all of that with 4 already, with Unreal Engine 4. Or with the early stages of 5. So the regular datasmith import was there. As I mentioned, the new library and the new tessellator was there since 5.3. But the combination of having datasmith inside of Interchange was allowing us to not only use custom blueprints, because that's something you could also do, but create pipelines that are repeatable. So, for example, if you import something in the regular datasmith and have a custom import pipeline, then it's going through once, and once you hit re-import, it ignores your pipeline. So that's why we thought the interchange pipeline is basically what you want to have. You have different injection points in your pipeline. So you have more or less right after the translation. So you don't tessellate stuff, for example, you actually don't need.
Like all that.
Exactly.
I forgot what you called it. Manufacturer
information. Tolerances and stuff like that. Then you could do once the U assets are created. And I come to that later on. We added a script that was shortening the name because of perforce and so on. And you can also apply post-import actions like substituting materials, creating UVs on the fly and stuff like that. So this was helping quite a lot to automate the data import process and giving us as much as or the best possible base before we start actually manual work.
Having
there.
the UVs, you know, as part of that pipeline, even as a baseline, right? Because you can go back and tweak them. I mean,
Yeah, that was one of the things I
insane.
was going to ask, because it didn't look like too much stuff had UVs on it, but obviously some of that stuff you can't get without having UVs. So that's
Yes,
really
yeah.
it's and this little part right here, the this is this part of the 3-hour import, or is that just to get the data ready?
Yeah, that was just for
Okay,
the test
okay.
import. The more pipelines you add,
The longer it's going to take,
yes.
but
Oh,
you will get a really nice result when it's done.
So the return on invest is worth the time you invest up front, and it's not that much. It pretty much depends what you actually put in your blueprints. The name curation, for example, was quite a pity thing because it was not just reducing the names because you want to kind of keep the original name somewhere. So you took the original name, write it into the meta information alongside with the original path, and then shorten the name, because otherwise you cannot.
Like 64 character limit or something like that.
Yeah,
it's the Windows
it's
thing.
the Windows thing. And Perfos is even more restrictive. Perfos is 220 characters, and Windows is 255 something.
Yeah,
or
yeah, and that's
250.
it's all because our friends in the IT department don't want us to corrupt our data, right? So
Mhm.
there's every organization has a different enforcement, but in our case, yeah, you know, and the thing about that CAD data is sometimes it'll have 7 or 8 underscores in there to
Yeah.
kind of describe something, but we can you know,
Yeah.
we can collapse it
Yeah.
down. So
And it also had German Umlaute in there, and special characters like the tilde and question mark and stuff like that. So really stuff that should not even be there in the construction data at all. But sometimes that happens, and most of the engineering people work on a Linux machine, so actually nothing happens. But yeah, these are all special cases, and that's something you need to take care of. Also, you have some keywords that are almost identically, but you have maybe a typo in there. So you have here, for example, Glasfaden and Glasfladen.
Fladen? Which one is correct? I'm going to say the top one.
Yeah, the top one is correct. So I don't know if there is actually a difference there, but it looks to me like a typo. Yeah. And stuff like that. Yeah. And for the name curation, we were also able to set the maximum length and also add a hash length afterwards so that it is unique.
Oh, okay.
Yeah.
Blueprint's so cool because
that's almost like adding a GUID to it, basically turning it into a GUID pretty much.
Yeah.
And Blueprint's so cool because like once you get used to it, you know, once you get used to looking at the spaghetti, like you can really break it down into, you know, those steps.
My other favorite thing about Blueprints is, well, Unreal's like a giant text pad document. So once you have done something once, it is really easy to be like, dude, I did this over here in this project. Let me just copy this little bit of code over and plop it down. Boom, you've got something going really fast.
The library, like it's amazing.
So what this actually looks like in the editor, before you start, you need to actually activate the datasmith for interchange import, because it's still experimental. There are heavy reworks for 5.6 going on currently, so that will get an even better code base for the 5.6 release, or for the 5.7. I don't know which release it will be.
Future release.
Future release. Yeah, exactly.
Yeah. Don't tell anybody it'll be fixed in quote 2 weeks.
No. And what you then can do is you go into your project settings. Then you have the interchange section here.
This will be newly added once you've added the plugin and restarted the editor.
Exactly. Import into scene. Yeah, and then you have your pipeline stacks. It's, for example, possible to create your own scene so that you can have a scene for I don't know, CAD import, a scene for FBX import, and you can fire up different pipelines per.
So a scene would
use
be
case.
like, in this case, like a level. I could have a level for my CAD, a level for
No,
my.
not a level. It's importing into the level, but it's
okay.
really different pipeline stacks that
Okay.
can be run. And on the very bottom, you have the Interchange datasmith translator, and there you have the Interchange datasmith default UI, which pops up when you import, and then you can, for example, define, okay, what do I actually need to see in this UI?
Very
so
cool.
pretty much the standard interchange stuff, but also very specific options to the CAD import. For example, what happen, and also you can define what happens on re-import, which is
makes it easy for your users because we're really technical. We're laying the framework. This is the foundation, but then the users only for documentation, for training purposes, it's really important to us that you can control it.
Yeah.
And this is great because you can basically everything is able to be exported or be viewed, but then we narrow down our scope to what exactly applies to us, but we don't have to bring in a programmer to do that.
Yes.
And you can teach people how to do it. Yeah.
So in an ideal case scenario, this is going to be set up from a technical director or a highly skilled technical artist. And then once the pipeline is established and set up, you hand that over to your artists. And having everything stored in a plugin, as Flo showed in the very beginning, is helping you quite a lot because then you can simply just share the plugin or put the plugin even on a shared drive.
Or your templates or whatnot. Yeah,
exactly. So a couple of things to go through. So you have the possibility to create your own material for the material instance. So for example, if you want to create a shader that has two-sided enabled as a basis for your all your imported shaders, you can do that. You can search for already imported CAD shaders, which we did to reduce the amount of identical CAD shaders. You can activate Nanite per default.
That's huge.
Which is giving you a lot of performance after the import. And further down here, you have, where is it here? The re-import settings. So for example, if you have deleted something out of your imported data set using the script, the data table, and you remove it out of the data table, then you can just force re-import and tell Datasmith, okay, I remove it now out of the data table. I push re-import, and then it should appear back up in the scene.
Maybe we should talk a little bit more about Nanite.
Yeah, I was going to say, Nanite, let's talk a little bit about that because it's not only for performance, but also for size on disk as well. And there's a lot that you can do with Nanite.
Exactly. Nanite. So as I said, you can activate Nanite on default via Interchange. We did that. And of course, you had to deactivate it manually later on for all the translucent objects, like the windows and the lights and stuff like that. So what we found out that especially one second.
You
need to make that a bit bigger. So the position precision is something you might need to tweak based on the shape of the geometry. We had in the interior very thin lines on the ambient lighting with very small icons and stuff like that. And when it's curved, the auto resolution is not always keeping up the shape. So you had to really tweak that manually, give it
especially for like
minimum precision,
thin objects or
yes, exactly.
Planar objects.
Yeah. So that you also avoid C-fighting through that. When it comes to the car paint parts, to the high glossy parts, you would want to increase the normal precision. We found out that 12 bits is quite a good sweet spot between the memory footprint and the visual quality. Let me just see if I can
And
demonstrate
the main
here.
thing that this is going to be affecting is the quality of your reflections on
Yeah.
those surfaces, right?
So if I put
a lot of
that-
times I encounter this when folks have like panel vans or something that's like a really long flat piece. You can see the effect.
So you
here.
can see the effect
Yeah.
here. Yeah. And if I put it back to 12,
It gets a lot smoother.
It's way smoother, and you won't get it any smoother.
That's
Yeah.
What you can do is you can use explicit tangents, which is then using the imported poly tangents instead of the nanite generated tangents. And then you can reduce, or you have the auto here. What happens if I put it to auto here as well?
Yeah, it
So-
falls apart a little.
It falls apart a little.
And then you can, of course, tune it here. And in the end, you can use the nanite stats to see which trade-off brings you the best result.
Yeah, how did the streaming pool end up here? I can't recall because we have how many parts do we have in here again? The actors.
24,000
Yeah.
roundabout. And that's actually a good way to debug that. So we have
I think it's stat
disabled. We disabled the
Oh.
online.
Okay.
So you can just enable. It's enable type enable screen messages. Yep, that first one. Yep, there you go.
Hey, all right.
So
We just didn't want to have a noisy interface earlier.
yeah. So in this case,
Yeah,
the monitor resolution
Yeah.
isn't good enough.
So
So
used to working at 1080. That's fun.
yeah. And to see all, we need to.
So that was stat nanite streaming to see the
Max
pool.
per group was set to, I think, 25 as a default, and set now we have
There we
everything.
go.
So exactly. So the nanite streaming pool size is defined with 2K at the moment, which is the absolute limit. We have quality scale is showing you the actual quality. So 1 is highest quality. If you run over the pool size, it will reduce the quality.
Okay.
In order to see, for example, what pool size you actually need, you can force the quality scale to 1 via the CVAR. And then you run over the buffer and see, okay, I need to increase it. But we were pretty much overwhelmed to see that even in the interior, you have a streaming pool size percentage, 26%, so
Absurd.
400 megabytes roundabout, which is really crazy given an amount of objects we have in there.
And that's how we're so confident to have this all running is as we're building and debugging. It's like we have overhead here. We have room to play.
So you always should take 200 megabytes of overhead into consideration. So the actual streaming pool size in megabytes plus 200 megabytes should be enough.
Cool.
It pretty much depends on the environment as well. So it's not only the car. We had tried out other environments that were crashing the scene because they used so much VRAM and has blown the memory the nanite streaming pool size. So in the end, it's a combination of both. So but that is giving you quite a good impression on how you debug that. And the changes you made to the actual geometry using these different settings for nanite, they don't have so much implication on the performance, but more on the memory footprint. So you can also see how the memory footprint then progresses.
So it's not necessarily going to make it run faster, but let you have more on the screen at one time.
Then I guess talking about nanite is the perfect handover to Florian for the nanite ray tracing and all his magic he did with the CVARs.
Perfect. Okay, so I will make this quick. I will speed through it a little because we are quite a little bit behind in schedule, and we want to send you off into the
we're
break.
fine. We're fine.
No, but we're fine. So the first thing I want to call out here is, I don't know if you guys knew about that, but if you search for console, you have the console variables editor. Super, super handy, because what it allows you to do is, so it allows you to watch all the console variables and their values and where they are set in one place, and it's also updating, right? It's a watcher. And you can also save those, right? So you can up here, you can create your own, right? You can add your own if you want to, and then you can save those as a preset, and you can share them. So we have like 5 different ones in here. We are only using this one, but you can share them easily. You can hook them up to your sequencer and so on, and switch per different shots and so on. So super, super handy, especially if you're like jumping from exterior to interior and you want to set things that are not available in the post-process volume. So let's just quickly go through that. So obviously we're, not obviously, but we are using ray trace shadows. Just mostly performance, visual quality. I really like ray trace shadows. So we're using, so this one is rather interesting. It's the Screen Probe Radiance Cache Grid Resolution. The standard is much lower than what we have set here. We did not see a visual impact, but it helped with performance. So this is something you can, especially in 4K, that you can trigger and can control. We choose to not use any screen traces whatsoever, just to keep all the reflections clean and not have like a jump where objects are just moving out of the reflection and so on. The other things that are more important, so the screen probe gather downsample factor. It basically it's another kind of resolution toggle for Lumen that allows you it's mainly for performance gains, and we obviously cranked it up to the point where we had no visual impact but the best performance. Refraction quality, so we were choosing no refraction. Just again, it's sometimes still hard, translucency in Unreal. So we were choosing this one. What we are doing is we are cutting off just to get in 5.5, really, you don't really need it anymore. But we wanted to make sure that we are not overshooting with any values for the lumen lights, so we don't get any fireflies. And 10 is really it's a good value. So we are, as you can see, we are not using nanite mode. This is a deliberate choice. So what this does by default, the ray tracer does not see the nanite mesh, just doesn't see it. So what you need to do, or what it sees, is the proxy mesh. The proxy mesh is a reduced version of your mesh, and this is what the engine actually sees. With this toggle, you can make the ray tracer actually see the nanite mesh, but we had a little bit of trouble with sequencer, so we with the camera cut, so we turned that off inside for the sequence. We are still using it once we are done with the sequence. We are still using it just to have the best visual quality. Now, this is just culling related. It's performance. Don't touch it. It's fine. Ray trace culling, we didn't want to have any ray trace culling because we obviously wanted to see everything. Again, don't touch it if you don't know what you're doing. The ray tracing normal bias, it was one of those things that we tried before Andy figured out the correct nanite settings, just to get rid of visual errors and so on. So you can also ignore that one. And these two are really to boost the max nodes and the max available clusters for nanite, so we could actually show and render everything without having a visual compromise. The other thing that I want to talk about is the lighting. It's super simple. So again, you go into going back to my previous statement with the plugins and so on. You just go into your environment, and then we have all the lighting in here. So never mind about this direction light, it's off. It's just for sequencer. This is our actual sun, right? Everything is obviously dynamic as usual. Lumen. We have a height fog. We have two different post-process volumes. One is the volume if you're outside of the car, and the other one is if we are inside the car. It's mainly about exposure in a couple of different settings. The other thing is we have some rect lights around here. Oh, let me show those just to get some bounce light, right? So we have one here, we have one here, and we have one here, just to get some bounce light for the shadow, for the darker side of the car. And we have a skylight. It's real-time capture in our case because we wanted to switch the environment into something else and have that possibility. This is easier. Obviously, you can also just use an HDR, and because the skylight is part of, and everything is dynamic, right? And it's part of the actual level. Once you swap out the level in your application, you basically just swap out the whole lighting. And in terms of post-process, so what we were going for is, so these are just the changed ones. Again, no screen traces, right? We use high quality translucency reflections. You always want to use that one for car environments just because your glass just looks much better and you get proper reflections, right? You can see that in here. Here we go. So high quality and low quality, right? Has a performance impact, but it's negligible. As we don't need any refractions anyways, one bounce is perfectly enough for this one. The other thing is we only cranked up the lumen speed, and the rest we left everything at 1. So there is no, like, there's nothing special in here, right? No magic, nothing. What I want to show you though, that's my last point before the break. So in the interior, right? So we have a different post-process volume, and I want to call out the ray light mode. This is new in 5.6, and what it allows you, so obviously use, so the different settings, right? We have surface cache, that's tracing against the surface cache. Obviously we don't want that for our car because we want an actual reflection. And HID lighting for reflections is what you guys are used to from prior Unreal versions, which basically means the reflection portion of Lumen. So we have two portions, right? We have the GI portion, which is all the diffuse lighting, the bounce lighting, and so on. And we have the actual reflections, right? Everything that is like a sharp reflection and so on. So in the material that's diffuse and it's or base color and specular color. And with this setting, you're ray tracing only the reflections, which is perfectly enough for, like, everything that you've seen up until now was only using HID lighting for reflection. What we can do, although for the interior, because we have this the emissive interior ambilight, you can use HID lighting, which basically means that also the GI portion of the of Lumen is ray traced. And what does that mean? It means that we get proper, that we get proper emissive GI ray traced from our emissive lighting. I'm not doing that because 3090, and it's not great on my 3090 in 4K because it obviously has a performance impact. But the last thing I want to show you guys, so this is not, again, this is not faked, right? This is an actual, this is the ambilight, this is the so-called Lichtleiter in German. This is the actual geometry that is just using an emissive material and is actually, like, all of this is bounce light, right? The same is for all those panels. They are all dynamic, they are all emissive, and they are all contributing to the light. And with that, I think it's time for the break.
Yeah.
Stay
Go
tuned.
ahead, Sam. Yeah.
Stay tuned, guys. We have one more thing for you guys after the break, and I guarantee you, none of you has ever seen it. It's a world, basically, it's a word premiere. So stay tuned and see you after the break.
When we have these data layers, we have this world partition, we have these levels instances that we can play around with. You know, a lot of the stuff that we do is modular and system based. And that's, you hear that a lot from me because as a technical artist and as a technical kind of person, you know, I don't want to do things more than once, right? We're generally lazy, right? We want to do it once, we want to put it in the can. So, you know, Flo talks about the data layers system and how we leverage that. The way that the world's set up is we have a level instances in here that will basically dictate what is going on. So I'm playing, so we'll just do this. So I'm going to do this live. It's a little dangerous. We just threw this together this week, but we wanted to show you the power of Unreal and where things are at. So we made a dynamic menu here for the environment.
Very cool.
And let's see what happens. So the first one's the desert, and the second one is the city sample. So we just loaded up the small city sample with a click from a dynamic UI, just because we had a level instance in there. And it's amazing because now you can start to explore the car in all these different contexts. And because we're using modular systems, you know, with a little bit of, I'll get the mouse out of the way here, you know, I can still do the same stuff I did. What's really cool about this, and I'll go into the details, is that the car isn't in the same spot. You saw it jump. So Flo was able to go in and select this spot specifically. It's super high contrast, you know, it's kind of a completely different shot, right? But like, as I'm going around here, I still have the same functionality to be able to, you know, pull things apart, put them back together in context in a different area. And again, just, you know, I say it all the time, but this is a live experience. I've got hotkeys here. So the environment buttons, right? What did I just show you? Well, we loaded up the entire city, small city sample, not the big city sample, the small city sample. We could fly all over the place. And there's a relationship between the level instances that we used and the data layers. So just to recap, a data layer is an asset, and it's part of the project. And that data layer asset gets brought into a level. So here we see it here. That's the desert. This is the small city. And in that data layer, we can set its runtime state when it loads. So you notice whenever I start the experience, we end up in the desert. That's because the desert's data layer is set to activated. And that means activated at its initial runtime state. And we can also set it for the editor. And that's why that world partition, large world, one file per actor, that whole thing just enables this. Because if I don't want this to be loaded and I don't want it to be visible to like you, like let's say I pass you the project, I don't want to blow your machine up, I just uncheck those two boxes. You can always opt in. You can always load in when you want to. But that's the foundation, right? We have a data layer in the level, and we've associated, in this case, just the level instance. I didn't have to add every piece of the city or every piece of the desert. All I had to do was add a level instance to my level or my map. And I just had to pick the data layer that it's associated to in the bottom here. So normal level instance, you just give it a map, right? But yeah, it's really powerful because now that association, right? There's a direct relationship now in my project between the level instances and the data layers. You unload the data layer, you unload the level instance. And because it's a level instance, you get all those benefits, right? Another core
sorry,
yes, Flo,
Mike.
please. Yes.
Just to highlight that again, this is really, so this is the whole city sample, and the performance is basically identical to the desert environment. Just because I saw the question before about obviously this environment is very reduced. The city sample is like, you can zoom out, it's the whole small city sample, right? It's all the geometry, it's all there, it's everything is in there.
Yeah, it's crazy. It's really crazy. And I mean, I'm not afraid to do it again.
Now it will die.
Yeah, of course, because you know, demo death, but I'm not afraid of it. So
But also, just once this is running, just blow it up so the people can see that it's still. doing
Oh, blow
that.
up the car. Yeah.
Blow
Yeah.
up the car.
Pull it apart.
So
Yeah. This all
the whole
works.
system,
Yeah,
right?
yeah, the
It's
whole
it's all
system works.
working.
Yeah.
It's all super dynamical, so we can obviously still change everything in there, the whole lighting, everything to how you want it to.
Yeah, what's funny, and then this will kind of drive it home, like this I set it up so the sequence it still works. And you're like, what am I looking at? You're looking at the fact that this is a real runtime application. It's still pulled apart, right?
Yeah, and it's
So
still using the lighting from
the desert,
my
yeah.
sequence,
Yeah, from
right?
your sequence. Yeah, not really the desert, but from your desert sequence, right? But
So
like,
as you saw, we really slapped it in last week. We just wanted to show you guys because we knew this would be possible and blow everybody's minds. And I mean, if you stop it again and go just to the interior shortcut quickly.
yeah, sure. Yeah, let me use that controller for
So
that. Easiest.
you can do
Yeah.
that, or you go into the
There
camera.
you go. There you go.
So as you can see, it just works, right? That's
Yeah.
the neat part.
Crazy.
You can just place it into the city sample and it just works in and out.
Yeah.
So
Yeah, it's amazing. Again, it gets hard to keep on time with these kind of things because you just want to play.
we're getting too nerdy.
Yeah, I just want to like, pull things apart and do all kinds of crazy stuff. But the thing that we wanted to show today is that, we come from production. We've done this kind of work for many, many years now. So we're really pushing the editor to make sure that, like Sam said, these UVs need to be right when you're doing the work. This can't just be close enough, right? We were having a lot of fun just kind of pulling it apart and looking at stuff.
Especially the glass. The glass was that I still can't get over that. It's the cool thing about the glass is that one was actually done in the material, but there's other parts that are actually done via static mesh, and it's impossible to tell which is which I thought was really cool because you could always see when a mask breaks down. It's pretty easy to see that.
Oh, so you're talking about the primer, right?
Yeah,
so
why don't you talk to that, Flo?
So the primer is, we ended up doing this with the texture baking, right?
No, it's really.
Is that the geometry? I wasn't
a masked
sure.
material in substrate, and it
Right.
looks like actual geometry.
Yeah,
Yes.
it's crazy. Let me get on the inside and look up, maybe. Sorry, let me get my buttons here. Sorry, guys.
So obviously that is a huge that is a
That's what I'm looking
huge advantage because you don't get like any text like any flickering or whatsoever, right?
Yep.
It just works.
Just want to.
So we
it
ended
stop,
up using the modeling tools to create that, and I'm not sure if you are talking about that, Andy, later on.
I mentioned it on the UE Fest talk.
Yeah.
So
Okay.
I will skip that. It looks like geometry,
Yes.
but actually it uses a texture. As you can see here, it's just
it's just an opacity mask.
yeah, it's just an opacity
Yes.
mask, and
Yes.
substrate is doing that
Doing
for
the
us,
magic
and
for
it looks like geometry.
It does look like geometry.
Yeah.
But the thing that I want to highlight here, because obviously this is rather standard, the highlight here is really that we created this inside Unreal with the modeling tools.
Yeah.
That's even
So
cooler.
we did not have to leave, because obviously these are the kind of things, right? You want this to be a texture to work properly, and to be map-mapped properly. And the thing is, we did not whatsoever want to leave the engine.
Yeah.
We really just wanted to be part of this experience, part of this workflow. And the project was also to again, we wanted to push Unreal, so an actual production like this could be done with inside Unreal, and you don't have to leave the engine.
So we'll get, this is, there's so many different ways we can take this project. I'm glad that we have such a amount of time today to kind of go through that. And it was really fun pushing it with the city sample, and seeing where we could go in such a short period of time. Okay, so now that you understand what you're seeing, which is really important, we don't want to talk too quickly, and we take some of this stuff for granted because we love it and we live in it and that kind of thing. But one concept that I want to make sure everybody walks away with is that the data layer assets are an editor asset. You're defining it in the editor, you're putting it in the data layer outliner. At runtime, that data layer gets instanced because it's a game, right? Everything's instanced. If it can be, it saves memory, it does the thing. So what I chose to do on my placement node, this node is basically what Flow got to place around. Again, it's just an actor blueprint. Sorry, I don't have that in that screenshot. I'll go over here. But basically, it's the same thing. It's a new blueprint actor class that I made, and I added a few neat things. So like I have a visualized bounds. I put a cube in there with the idea that we can take and put a min and max bounds on that, so that you can kind of say a vehicle of this size would fit in this spot. Right? Because you can put that logic in there when it moves. It's like, can I fit there? Right? And then, as I mentioned, the data layer instance and the data layer asset, I'm actually capturing. It's super easy. All I had to do is basically just get the instance from the asset. And so, you know, one of the logic points that I wanted to put in is like, is there already a vehicle in that spot? Right? So what we have here is the BP TKO vehicle is my class for my vehicle. It doesn't have any parts in it. Everything we saw in the outliner is underneath it. It's just an empty blueprint that has a ton of heavy lift, right? So the currently assigned vehicle goes there. And so basically when the level changes, it does a blueprint interface and it says, hey, the level changed, Mike, click the button. And it gets all the level instances and it makes a valid placement in world array, so that basically if it basically builds a list out of all the data layers of all the instances that are only environments, because I'm getting them from the placement actors, right? And so each actor should say which data layer environment it wants to live in. And so quickly, because it's very similar to the camera system, basically the button is made the same way as the camera system. It's just looking for the data layers instead. And so the main thing that's different in this one, I want to make sure it's big enough. You know, when the level changes, it pumps in all the data layers instances, like the level change. Here's the level data layer instance that's coming up. And that's what's informing the system of what level to load. So first I look for the level that we want, because when I find that level, all I have to do, it's so simple, it's crazy. Like once you figure out all the nodes that you need, all you have to do is set that from loaded, which means it's loaded, but it's not visible in the game, to activated. And you saw me start and stop that thing, and everybody's heart skipped every time because we know how much of the city sample we brought in, which is all the small city. But all I had to do is basically, if I'm that level, like if it's me, and that's what we're trying to load, I just set the enum to 2, which sets it to activated. So this here is checking to make sure that it's not already loaded, because we don't need to hammer Unreal and say load, 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 right?
Yeah.
And same thing down here. If the level's already unloaded, just move on, right? But if it's not unloaded, then we want to unactivate the other level. So loaded means I can't see it, but it's still
In memory.
in memory. And the other one means I can see it. And then basically it just looks for a vehicle placement node that doesn't already have a vehicle assigned to it. And so it's going to look for a vehicle placement node and make sure that there's not one already there. And basically, this is what moves the vehicle. And I want to, it's a little low res, and I apologize. But what this says is move to placement location. And the important thing is that the target is the car. So this is the TKO vehicle that's being moved, right? So this car, so you can, now you see my system, right? Now I can have an array of vehicles. I can have an array of locations. I can iterate through them at, you know, when I hit the button, and it will figure it out for me. And I can set priorities, and I can do all kinds of developer stuff that I want to do, but I wanted to keep it simple. And basically, the other thing that I'm going to do is I'm going to move the pawn. And so this is the pawn, the pawn getting moved to the same location, right? And then the pawn gets updated to refresh the spring arm, the initial location, so that we don't end up, it's just like starting the experience over again.
Out of weird sync with something lagging behind something else.
And then I just took this snippet to show how, now what I would do is also make sure that if I move the car, that I clear that slot, right?
Gotcha.
So you can do it multiple times. And the blueprint interface concept took me a little bit, as a Python developer, as a more, word-based code, less node-based code. But that's so deceivingly simple. Like when you assign that blueprint interface event to another blueprint, you're just basically subscribing to it. And I want to show this because I always like to put a function or an event, right? And make that callback separate in my code base, in my blueprint, than the actual long form thing, because it's so much easier to understand and read what's happening.
That's very true.
So the last piece for me is the peel apart system. I think a lot of people want to understand that, so I'm going to take a little bit of time and go through that and kind of talk about how the pawn is interacting with the vehicle. So we have a pawn configurator, right? That we made our own pawn that we're using. And this is, again, I'm not going to drain it, but I just want to show the convention that I use here. So I know that anything in red is an event. Anything in blue is a hotkey. Anything that's green is played. This helped me so much. We didn't have a lot of time to do this project. We did it in a very short period of time. So every time I had to go back to the code base, I had to not have to untangle it. And what's cool is because I told you that, that this is begin play down here. So when we begin, so the main thing I want to drive is that, everything that you can do to make things at a glance organized makes it easier to figure out what you're trying to do. So if we look at the begin play, for example, actually, did I break this down? Yeah, cool. This is the one. Okay. So basically, this is the pawn. The pawn is doing a lot of heavy lift here, right? Because it's you. And I look at these objects, like you see, I have a car blueprint, I have a location blueprint, I have, our level instances and our data layers, everything's nicely sorted, right? The UI is doing UI stuff, the pawn is doing pawn stuff, the car is doing car stuff. The more you can separate those ideas early, and I have some architectural diagrams I use to sort that, this is the begin play, right? And so this static mesh preview is how we're doing that highlighting. And so basically, you're attaching and detaching from the components. You're using a line trace to try and derive the object, and you're swapping the highlight mesh. And so, my sequence of events, I thought folks would want to see how this thing starts, right? When you hit play, is you basically get the player controller and you set up the UI for the game input mode, and then you make sure that you're in the mode class that you want, right? And that you're actually getting the configurator game mode. I saw a question earlier about, couldn't you do this in the game mode? Couldn't you do this in different ways? Yes. Unreal can do anything in any way. But for me, it made most sense that I wanted the pawn to handle what the user's experience is, because the ideal for me is that I have a whole street full of cars. And as I interact with those cars, it's passing information back and forth from the car to the pawn. Because it's like when you walk up to a BMW and it has 2 doors, you know that you can open 2 doors. The car knows you can open 2 doors. That's a 4-door car. When you go over there, you can't be like, well, you only got 2 doors, right? Yep. Right? And so I try to break it up in that kind of logic and that kind of idea. And then I set up the HUD, which is a function. You see, these are functions. My main point here is it's easy to read. Right? It's easy to see what's going on, right? I'm setting up my variables for my intro sequence, which is that cinematic. And then we set up the spring arm, we set the target zoom from the spring arm's current setup. And then I'll get into this pull apart component. But the main point here is that this is readable. Like in 2 or 3 minutes, I was able to walk through this with you and say like, hey man, here's what I'm doing. And then you're like, oh, tell me more about the pull apart system, right? Like how are you you know, pulling that stuff apart, right? And we looked at it a lot, so I'm going to kind of show you under the hood how I made that thing blow apart. And it has to do with the editor utility widget. So in my plugin for our core content, I've got a peeling the onion editor utility widget. And if I run that widget, zoom out a little bit, I have another dynamic UI. Who would have thought, right? Like I would make
There's
a
this theme
dynamic
going on
UI. Yeah, it's weird how I'm trying to really driving that point home with this project. So what's happening here, and I'll go into details in a minute, I just want to show you it actually running, is that there's a struct that defines these layers. And this is my own convention. I call it, you know, the onion layer 0. And the numbers are what really matter to me. And so we have a lot of actors. And
33,000.
yeah, 33,000 actors. And I don't want to have to handpick them because, as I said earlier, I'm lazy. So what I can do with this system is I basically built some functions, and I'll show them in a minute, of being able to do the things that I, as an artist or analyst, would want to do. So this is a simple tagging system. It's really apparent what's going on. And I love that Unreal has those actor tags. Here, I'll just type it so I don't keep scrolling. Weird, it's written right here. So if I pick a part, you know, I could pick a part and go, okay, which one you got? I'll type this tag in. Or I can make a struct that has a list of things, and I can build a dynamic UI. And basically, if I want to add something to a layer, like let's say I want to remove that tag, right? So I just remove the tag. So I can pick this, boom, boom, right? Remove the tag. And if I want to add it back, I just click this and it adds it back, right? I know it didn't do it and there's reasons why, but I'm not going to check out a perforce right now. But the main point is it's that simple, right? And these buttons are dynamically built just like the other ones. Somebody asked earlier, like, why does your button know the thing and not, you know, something else? It's because I like everything to take care of itself. It's my choice. I want that button to know what it does, who it's doing it to, and why it's doing it. Because then when I come back or you come back or Andy looks at the code, it makes more sense. So these buttons are to set the layers. These buttons are to help you go, what did I just do, right? Oh, okay. Now what's really cool for Andy and Flo, and I mentioned this during my talk at Fest, is that now you can see inside the door easily. You're not sitting there trying to hide and show and isolate and all that. And you're like, nah, I need more gone, right? Okay, cool. No, I want this one gone too, right? Okay, cool. Now Andy can go in and go, oh, you know what? Our material swap missed on this one screw, right? So pick that screw, frame it up, right? Or whatever that is, little weld pointy guy or whatever that little cool guy is there, right? Let's say he was all of a sudden CAD colors. We noticed like in these crevices, you know? So having the fly around mode, having the pull apart mode, having this tool set, let them explore the vehicle more in ways that we never would be able to efficiently do. So, yeah, and now I can just show all the layers, everything comes back. And the other thing that I did for myself in this case, for the art direction of this, because remember, we use this for the this cinematic was used in the keynote. So there was a lot of attention being driven to like, how far do things move? What's moving? When's it moving? Why is it moving? And so I thought about that idea of like, yeah, this needs to be art directable. So like this set of tags could be used for like the data prep process, right? Like, yep, these are the ones that we want to hide and show on our logic. But then you could also set up a second tag. You could have 1 million of these because you're a developer and you can do whatever you want. Now I can have a secondary tag because actors can have as many tags as you want to give them. And now I have 4 levels I could use for a marketing system, right? And now down here, because I chose that, it built those buttons out.
Nice.
Right? It's not so much like how did I do it? I just thought about what I wanted, and I worked with Blueprint to kind of figure out how it's done. And I had a good foundation on like how systems should communicate and that kind of thing. So now that we've looked at it in the editor and you kind of understand the why, I'll show you the how really fast. So for the peel apart system, on the sorry, I'm just trying to make sure I know which one this is. This is on the pawn. There is a onion layer system category of variables. And peeling offset, we use 750 in ours if somebody's trying to play around with that. I just defaulted it at 100 so I could debug, right? There's a couple of things that are really visual. So the center of that onion is an actor that's in the scene. And that actor gets assigned by the pawn to be the center of where that goes, because you may want to blow it forward, backwards, down, from the middle. We chose to be like underneath the car in the ground. And so then I also have my vector, my curve that I use to animate it, right? And whether or not it's affecting rotations. And so this is basically a widget that is the basis, just like I showed you for the UI earlier. You can see this is what would go on if I didn't have any, struct set up or anything like that, right? These are the basic functions. And it leads to this. And while it is a lot of nodes, for what it did, what I just showed you is all right here, right? These are all the
looks like some of that repeats.
It does, because it iterates specifically around, yeah, sorry, here. We'll just walk it through a high level. Right here's the iterator, right? Here's the loop, right? And so for every button, it does these things. And then these are the cleanup operations and the other stuff. So, once you have your actors and once you know what you're trying to control, you can build out your functions in a way that, and again, this isn't the entire code base you're seeing, because I use functions to do the very specialized tasks, because I can reuse them elsewhere. And so, yeah, so basically then there's the main event that skins the transform out. That's done on the vehicle itself. So when that event happens, it tells it to peel and it does the transform. And you can see, again, I've broken the code down into functions so that it's easy to read, and I can go, oh yeah, boom, okay, that's what does that. So the other thing that I wanted to point out here is that there's two different events that you can call. You saw the one earlier where the white car was coming apart, kind of timed. That was so that Flow could play around and prove out for us that I could drive this from sequence. So the sequencer event's up here. So this gets called by sequencer, and you can set your variables on the way in. But then also the UI, when I hit the gear button, I have all these variables for speed and distance and all that, and like the time per cycle and the delay and whether or not to keep them visible. So then we go through that struct, like I told you about. The struct is basically a map. And it goes through each of the ones, make sure it's in range, make sure we're not currently transforming, right? What you would want to do in this is put this into a separate thread, right? So it could be asynchronous. Right now it's kind of tied in, so it's not asynchronous, but there's game ways to do this better. I just want to be forward about that. So here's where it finds the center actor that I referred to. It goes through the number that I've asked for, right? Because I could say, give me 5 levels, and it just goes off like a firework. And then I have some debugging, because, debugging is important. And then this is what actually moves the layers, right? So basically for the level that, make sure you don't go out of index, right? And it basically says, I'm moving something, and it moves it, right? And then it transforms using that function. And then when I want to put it back, I have an event that just sets everything back to its original set. And one of the things that I want to highlight here is 2 things that I did. One is that when we first started this project, we weren't moving it to the city sample, so everything was static.
Okay.
And I didn't want to check out 33,000 or 200,000, whatever number of thousands of files that we had. And so at runtime, when you tell it to do something, it sets it to movable.
Okay.
Right? And then I put it back. So basically at runtime, you can affect that movable static state on these things so that when Andy re-imports, I don't have to make him set it to movable.
Gotcha.
I know we're getting close on time here, but I think it's important that folks get, the time with this. I'm not running out the door. But the other thing that is important is that there's a key value pair here for an array of objects. And before I moved the object, the static mesh actor, I make sure I write down where it is. That's why in the city sample, it goes back instead of going back to the origin by just setting it to 0. It goes back to where it was when I hit the button. It's a 5 on the hotkey or on the UI. So tracking that stuff is really simple. And I used a struct because this is just kind of my catch-all, right? The structs, once you understand them, they're super powerful in Unreal because getting that key value pair can be a challenge. And then, yeah, it just sets back the transform to wherever it was supposed to be. And yeah, and if I'm affecting rotations, I basically just have a different path. So the other thing that we do is we hide the layers. So that's just basically a delay. And then it hides the layer. Hide actor array, right? Good old hide actor array. An emergency stop exists if it starts going haywire, right?
Too many parts are flying off.
Yep, I'm being open, being honest. Timelines can get out of sync. And here's that home transform. When you refresh the struct, this is what captures it. So when I refresh this struct, that clears the struct. Make sure you clear your arrays, right? And goes through for each static mesh actor. We'll get the relative transform and basically write it down. So that's the peel apart system. Then the pull apart system is a different approach. It uses so basically on play we get that detached from component static mesh preview, and we're attaching and detaching the component right to the object. And there's a concept in here that's called this pull apart component. Same idea. Right? The pull apart component's a specialized blueprint class. Instead of being an actor class, it's a component class. So that component can get added at runtime to my pawn. So now my pawn inherits that ability kind of right at runtime. And all I had to do is just add the component to the pawn. Okay. And again, you see my colors, so we know where to start, right? And I'm going to do it big here first so you can see like this is kind of the whole system. And I'm going to just kind of zip through it. But it's all based on a line trace. And we're using the query collision so that we're not doing physics stuff. We're just querying the hit. And basically on the event tick, when that system's enabled, when the overlay is not shown, we hide that preview mesh. And then we just do a sequence. And basically it's a line trace. So we get the pawn, we do a forward vector line trace, normalize it, and do it by channel. And then basically we're tracing the visibility channel. And then when it gets a hit, we break the hit and we're getting the hit component. So we're getting the component, the static mesh component that gets hit. And then, we have the component that we want to move. We make sure it's mobilities, where we want. And basically we set it movable if it's static because we have to be able to move it, right? Like I said before, Andy brought the stuff in. He wasn't really caring about if it was movable, static, or whatever. And then once that's set to movable, we're getting it static. We're making sure it's a static mesh component. We hide, if it's not a static mesh, we don't show the preview. Otherwise, we get the world transform of that component and we set it to the preview mesh. And, and it basically does the highlight thing that you're seeing. And then this is what actually moves it. So when we click, we're using a gate here to basically make sure that the components, there's something there. And then we're just doing the set relative location based on the input over time. So this is the controller version of that. So when I hit it with the gamepad, when I hit the button, just make sure we're in the mode, we clear the selection. And then we have a gamepad input system. And again, it's the same idea. So we're using the hit component to set that as the one to move, and then it passes to the rest of the system. And then we put it all back together with the same idea I just said, which is we have a list of those locations. We write it down, get a receipt, and we move it. So that's, yeah. So, you know, the user toolbox would be a great place to house some of these, like the editor utility widget that I use for like that peeling the onions system that I showed you. So I think, you know, one of the last things we want to do is just make sure that we revisit that one more time. Andy, you want to show them that?
Yeah.
Thanks.
Just a little housekeeping. We have one topic left. We are a little bit over time. So one topic left, and then the Q&A. So we have around about 10 to 15 more minutes. Talking about the user toolbox, before we do that, the question came up, and I've shown that on UEFest Seattle. It was about Python scripting and customizing the import.
Oh, yes.
We did do a Python script that automizes the import. So we had the root folder where all the CAD parts were located. We could define any type of extension. The import game location, this can be your content folder, but also this can be your plugin folder. Make sure, our recommendation is make sure to directly import it into a content plugin, because moving it later on can be pretty painful. Important thing is you don't want to have any pop-ups coming up that wait for you to click OK or import or whatsoever. So we have the parameter automated as true. And the cool thing is you can actually pretty much define which blueprints are called for the import. So you can say, okay, I want my CAD import filter. I want to have my UV. I want to have my naming script that shortens the path length and so on. And you can pretty much define it in that.
That's pretty cool.
File. So that's regarding the import. And the rest is pretty much the user toolbox. This was actually our lifesaver, because it saved a lot of time, a lot of, I say, mouse miles, because all the important functions we needed are either here, or you can just undock it and dock it in the UI wherever you want to have it. And there is even the option, but you need to restart that, that you have in the tab details, that it's visible in the viewport here in the small corner. You can extend it and then have your, I don't know, 2, 3 most important functions like an isolate selection and stuff like that visible in there. So looking at the command list, everything until here is built in, so you can already achieve a lot of that. I won't go over all the functions because I did that on UEFest. So if you want to know more about that, really have a look at the UEFest talk. What I want you to walk away with is that this is a tool that allows you to customize a UI window perfectly tailored to your needs. So in my case, it was really for data preparation. So I had import, I could toggle between the different tessellation values. I had the zoom mesh if needed for additional meshing algorithm after the tessellation here. A lot of scene organization stuff, geometry, yeah, the typical merge and flip normal stuff, mirror, and stuff like that. So I'm going over all these functions in the UEFest talk, so I won't cover them here. One cool thing, and I'm going to show that live because I'm pretty confident.
The famous last words.
Yeah, the famous last words. So, for example, let's say you have that hood here, and because we often get the question regarding the retessellation.
Okay.
So we did the finest possible, the smallest values tessellation on all of the parts, and see if Nanite can handle that. And if you can see, the performance is compared to what Nanite needs to do really, really good. But there is sometimes the demand of cleaning it like you do it in DeltaChain or in VRED or in other classical data preparation tools. So what you can do is using the modeling tools, but then you need to activate the mesh element selection, and it wants you to restart the tab. So we are going to do that. Right. And then I click on it and click on the polygroups. I need to unlock it. So, and this view looks pretty familiar to everybody who has worked in these applications. So what you can do right now is, or what this function does is, the classical modeling tools is like, you have to choose a function and select them. And what you know from other DCCs is select first and then add the function.
Okay.
And this is pretty cool. And if you want to know more about the modeling tools and all that features, Russell Paul did a great talk on UEFest Seattle. It is called 50 Tips and Tricks with the modeling tools. So that means you get 1 trick per minute, which is an insane beat. So make sure to check that out. So what you can do is now you can really select that stuff like you do on a NURBS basis. You can actually delete that,
or we could
offset it, or clean up,
trying or
yeah,
clean it up.
Yeah,
I was trying to say.
So and let's do that right now. So it's
There you go.
double-sided. So if I delete that as well, then I have a hole in it.
Yay.
And the cool thing is,
Those are called speed holes.
yeah, and the cool thing is the undo function works there as well. And once I hit the retessellation button,
Was that Control B, right?
Control B, yeah.
The best button ever.
Yeah. You can say tessellation rule everything, so it brings back the deleted ones. Or you skip the deleted ones.
Okay.
And it takes a minute or it crashes, depending. Yeah. The important thing here is that the information you need to tessellate the geometry is actually stored inside the static mesh and not in the cache. So for retessellating, you don't need the cache.
Oh, interesting.
So I have a pretty rough one now. So let's check it out. If it's still there. Did I delete this one?
Yeah, that one.
Yeah. So it's
still
still gone.
Don't save and check
Yeah.
it.
Don't save. Yeah.
Don't
Yeah,
save.
definitely,
Don't save like ever. Yeah. But that's something I wanted to demonstrate, wanted to highlight.
That's
because
very cool.
it's really great. And the same goes with you have the 2 color trims here. And for example, we have this cool script that merges all the material slots in slot 0. And now it's completely black, so the silver part is gone. And what you can actually do is you go into the polygroups, you unlock the geometry, and then you see it's really like in Alias or so. And then you can select it pretty easily.
And we joked about not saving, but don't worry, we're in version control. If he did save. And we had a few of those events over the use version control. That's what I'm trying to say.
Version control saves
your friend.
life.
It's your friend.
So, and then I can go here to attributes. Where is it? Edit materials. So the selection is still there. I add another material. Here's the name. Aluminum, polished, brushed, whatsoever. I don't care for now. So active, no, where's active material here? And then assign active, accept.
It did it. Nice.
Done. So
they're super powerful. Like watch Russell's talk. It's amazing. It's like a fountain of just amazing things. Like
I did not select everything for timing reasons, but you get the idea behind that. Yeah, as I said, toolbox modeling tools, very powerful. And this was the main reason why we did not leave UE at all to do certain data preparation steps because it was simply not necessary. In the end, as you can see here, the main reason for us, or the main point, was to keep the construction hierarchy. We did not do any merging. We did not do any data preparation in terms of cleaning and stuff like that. So in the end, we saved a lot of effort and a lot of time. And this is one of the key aspects we want people to go away with.
Being able to optimize an engine is very powerful,
Yeah.
especially like being able to optimize per face. That's kind of cool.
Yeah, and the cool thing is actually we also tried to export the whole thing as an USD and as an FBX and load it up in DCCs, and it's actually working. So
Round trip,
round tripping is also a possibility. And using Interchange, you can also define export pipelines, so you can further reduce it. You can use geometry scripting to reduce it down and do jacketing and stuff like that. And
what you're telling me is the next Gran Turismo is going to be real CAD data for my car.
We hope so. That's where we're trying to go. We're trying to push it. So I think I've addressed those questions already. So
yes.
I think that sets good. So I think maybe we've run over on time, so I'll pass it back to you, Sam.
All right. Well, welcome back, everybody. So we had a brief break, and now that we're back, we are going to be kicking it back off. Going to hand it over to Mike.
Actually, we've been getting a lot of QA in the chat.
That's right. We're going to do the
so
QA.
Maybe let's, we just noticed over break, we looked through some of the questions. There's some really great questions.
So the first question was, is this CAD cache going to be limited to Datasmith, or could this eventually come to Interchange? Thinking if we use USD and get the benefits of this cache. So far, this is something exclusive to Datasmith. I don't know what the USD initiative planned for further developing on our side, but if that's a valid approach, then I'm pretty sure they are looking into it. Is this going to be released as a plugin or available somewhere? Obviously, without the CAD data. I guess this is referring to the whole scene. As Sam mentioned in the very beginning, we are creating a package. Part of that package will be EDC articles, and these EDC articles will show you how we created these scripts step by step. A few scripts that we created, for example, for the user toolbox, will be added for the user toolbox for future releases. So probably for the next upcoming release. Yeah, the rest will be documentation on the EDC, and a few things will also be added to the templates.
But one thing to point out, everything here can be done with standard binary build of Unreal. There's not anything.
We are using 552. That is right from the launcher. There is no secret source, no custom built stuff in there. So it's all right out of the launcher. Did you try to incorporate the soft model geo into the CAD file before export, or did you import multiple different file formats but to the same destination and organization? So yes, there are a couple of ways doing that. You can obviously, if you do your soft modeling, for example, in Maya or Blender, you can convert these polygons to subdivision and to NURBS, and then hand it over to CATIA, for example, or to Siemens NX and other CAD softwares, but and then treat them like a regular CAD import with tessellation and stuff like that. But out of the experience, that's not worth the effort anymore with Nanite. In the past, I know we did that to save polygons in the end, but with Nanite enabled, it doesn't make any sense. So what we did there was we set up different import pipelines for the CAD files, and then another import pipeline for FBX import, for example, for the soft model geo, to import them into a plugin into the content plugin of the car, into a respective folder, and then it's also getting added into the scene. So that's more or less, yeah, how we did it. What about alternative file formats? So we do support every industry relevant common file format. So be it JT, PLM XML, CATIA, Siemens NX, SolidWorks, Pro Engineer. So everything you name it. Even Alias. Alias has just one special thing. You need to have Alias installed on the machine you're trying to import wire data into Unreal. That is because some licensing stuff and Unreal needs to check for the wire DLL, so you don't need a valid license for the installation. You just need to have that installation on disk.
And that's across all softwares. So that makes
Yeah.
sense.
Yeah. Is sorting assignment of the single meshes to particular data layers part of the interchange setup? In our case, no, because we learned how to set up the world partition and the data layer setup during the project. But if you pretty much know what you want to do, you can actually assign during the import based on metadata or on name tags your stuff, your CAD data to different data layers. So that's possible. And then there was a question regarding UV mapping. How long did it take on your end with a currently presented example? And can you confirm it's faster or slower versus existing DCCs? So it was we did during import a triplanar mapping on a UV mapping on all objects. Used a fixed scaling factor because most of the OEMs have physical samples that have a specific size. So in this case, it was 10 by 10. And I did run it afterwards as well, because I had to change something in the texel density scaling. So I had to rerun it, and it took minutes. So it was not that long, maybe 10 minutes for the whole car, something like that. And then we obviously had to manually unwrap a few parts in the interior. But the unwrapper did a pretty good job considering that we did not clean any part at all. So you have double surfaces all the time and stuff like that. So yeah, that's and the unwrapper is dealing quite good with that in terms of quality. Regarding the import time itself, it pretty much depends on how your data is structured and how many parts you have. So I have data sets that import in less than half an hour. I think the fastest was 22 to 25 minutes. That was for a 100% car. If you have 150%, it varies pretty much on how much assemblies do you have, on how much parts do you have, and obviously also on is it slow or a fast SSD.
All right, well, that is going to wrap us up. Remember, if your question did not get answered, we're not ignoring you. We are going to answer all of the questions that were asked in QA in a separate email. It's going to go out after this, contain links to various articles and things like that we went over. And that's going to do it for us actually here. So thank you everybody for coming. I know it went a little bit over, but we appreciate you staying with us, and we'll see you next time.
And thank you for our crew behind the scenes.
Yes, thank you for our crew behind the scenes, handling your questions, handling our videos.
Thank you, guys.
Thanks.
Thanks, everybody.
Have a great day. Ciao.